Hello and welcome to the Daily Space. I'm sorry for getting started a little bit late. The science was going on in our office, which delayed the science communications in our office. Uh, for those of you who don't know, those of us who work here at CosmoQuest are not just people who hang out on Twitch communicating science and hopefully putting astronomy into your brains. We're also a team of active computer scientists, psychology and sociology researchers, and of course, astronomy and planetary science researchers. So, in the background, there's always new information being generated, and we are always trying to add to the knowledge of, well, what humanity knows about our universe and what we know about how to study our universe using citizen scientists. Now, one of those things that would make me really happy is if those of you who have some spare screen real estate could click on over to cosmoquest.org and work on mapping out worlds while I work on telling you science. So I have the chat, I have the science, and I'm going to switch screens. So in our first result from the day, we have new discoveries that in this case were made by high school students at a university, not a university, a high school in Salerno, Italy. What has been going on is we used to have this amazing X-ray telescope called XMM Newton, and all of its observations have been made publicly available. And one of the things that various teams have been going through and doing is using automated software to build catalogs of those objects that don't stay constant in time. By looking at these particular objects, there's always the case that, well, interesting kinds of stars will be found, or perhaps even phenomena we've never seen before. In this case, it was the latter. This group of students from Serrano's high school were able to uncover this particular object, in this case, the one in the bottom of this set to the right, every once in a while undergoes a massive flare. And it does it for a very short period of time, less than 5 minutes, it appears. Now, this is not the only X-ray flaring object that was discovered. It's simply the one with the shortest duration, and it is one of the brightest. So now the team of scientists who have made themselves regularly available to work with the high school students who are going through and visually examining all of these varying objects are working together to try and figure out what kind of an event could cause this particular X-ray object to suddenly flare up so much in brightness. This is one of those cases of why we need citizen scientists. Here, our citizen scientists aren't just random people on the internet who I personally love, but instead they're students that are working on a school project. So they're essentially targeted to do science, you might say. But they're just everyday people, just students going about their student lives. And because they're looking at each image and looking to see what goes weird in the night, they were able to uncover a new kind of behavior. So if you ever start to hear someone saying, "I can't do science, I'm a," don't let them finish that sentence. Instead, tell them that there are never before known about X-ray flaring objects getting discovered by Italian high school students. And that person is fully capable of going online and helping any of many different programs in many different sciences learn more. I would encourage folks, if you haven't ever, check out scistarter.org. They're one of our collaborators, and they're building a catalog of all the different citizen science projects that are active and out there waiting for you to participate. Now, in our next discovery, we have one of hot Jupiters. This is a depiction of, well, the phases that we might observe from a hot planet as it goes round and round its far too close star. Hot Jupiters are planets that are perhaps a few times bigger than our own planet Jupiter, perhaps the same size, but orbiting inside of Mercury's orbit if Mercury was orbiting the same stars they were orbiting. All of these hot Jupiters are orbiting alien stars. These are what are called exoplanets. And when we look at them with powerful telescopes capable of measuring the composition of their atmospheres, one of the things that we find is these hot Jupiters don't have water vapor in their atmospheres the way we would expect. Now, currently, we're only really able to see and measure the atmospheres of these stars where sunlight from the star it is orbiting is passing through its own atmosphere, superheating that part of the atmosphere. A team of scientists working at the Jet Propulsion Lab have been doing a detailed study of how is this possible? The issue is we know there's lots of planets out there. We know that our own Jupiter and Saturn have water vapor in their atmospheres, and we want to believe that similar planets should have similar compositions because they're all born out of similar solar system nebulas. So the question becomes, where does the water go? Well, the scientists working at the Jet Propulsion Lab, trying to uncover the mystery of the water, believe that in the presence of the strong ultraviolet light that these planets are receiving as they orbit super close to their home stars, that ultraviolet light is able to tear apart the water molecules, and the various constituents are probably going ahead and becoming part of other molecules like carbon dioxide and carbon monoxide. It's thought that on the other side of the planet, the cool dark side that isn't facing these planet stars, that on the presently dark nighttime side, that water vapor is present in the atmosphere. Now, unfortunately, we don't currently have the technological ability to go ahead and look at the dark side of these worlds. This, when it launches, and let me go ahead and give you a sense of when in the planet's orbit it's able to have different kinds of molecules. It's thought that and here, this is daytime, this is nighttime. So when you're most on the daytime, the water goes away. When you're most on the nighttime, you end up with all sorts of complex molecules forming. And in between, you have a mix of various molecules and atoms. It's hoped that when the James Webb Space Telescope is finally able to launch, that it will have that capability of measuring the chemical constituents that are present on the nighttime side of these worlds, that it will be able to essentially test whether or not this plot put together by the good folks at JPL is actually true. So this is what we're hoping, and this would indeed allow us to confirm daytime means no water, nighttime means, hey, water, ammonia, and methane all present and accounted for. Now, just because I want to hit on this one more time, we have 2 amazing days of science. Tonight is not the peak of the Perseids, but tonight at 3:30 Eastern on what will be at that point August 11th, we have the Parker Solar Probe launching. Now, the Perseids are already going on. They're just not maximum happy meteor shower. So, if you go outside and start observing around 11, carry your laptop out with you, maybe throw some red cellophane over the screen so it doesn't wreck your night vision. You can lie out in the hammock waiting to see if the solar probe launches and, well, watching a meteor shower that is just in the beginnings of, well, showering us with space debris. Tomorrow night, the night that starts on August 11th and ends on August 12th, tomorrow night will be the peak of the Perseids. The peak will occur wherever you are in the world at 11 p.m. local, unless where you are doesn't follow the normal time zones. So take care to account for that. And the reason that everyone in the world gets the Perseids in their own local time zone is we have to wait for the Earth to rotate so that the part of the Earth that is touching the debris field of Comet Swift-Tuttle, which left behind the debris that makes up the Perseid shower, we have to wait for your part of the Earth to be most pointed at that debris cloud. It turns out that for all of us, when that occurs, it's 11 p.m. local, our part of the planet is, well, receiving the most direct hit it's going to get. Now, the Perseus constellation is one that's kind of hard to find. The best thing to do, honestly, is to look for the W of Cassiopeia. When Cassiopeia, as is shown in our screen over here, when that constellation looks most like a W, shoot off of these middle 2 stars on the flat side of the W and kind of arc down towards the horizon off of them to the nearest bright star, and that is part of the shoulder of Perseus. So that's how I find it. It's not necessarily the best way to find it. Another way to find it is to take the absolute flattest part of Cassiopeia over here on the end of the W and just follow it down towards the ground. And as you follow it down towards the ground, you're going to look through the constellation Perseus. And that's where all the stars should be originating. So, tonight's the night, folks. We will hopefully have a solar probe launching on its mission to be the first spacecraft to enter the sun's outer atmosphere. At the same time, we have the beginnings of the Perseid meteor shower, but the true excitement will be tomorrow night. So if you have the opportunity to sleep in on the weekend, this is the weekend you want to pick. Stay up late tonight, get the solar probe taking off. This is assuming you're in the United States or other places that share the same time zones. So I'm looking at you, Canada, Mexico, Colombia, all of South America, Paraguay, Patagonia. Get out there, watch the Parker Solar Probe take off. And that's pretty much the stories I have for you today. As a reminder, next week I'm going to be taking off for the International Astronomical Union, and the week after that we will be bringing you live coverage every day as the science is made. So if you have any questions, go ahead and at me in the chat. As always, the Daily Space is brought to you as part of CosmoQuest. We are a multi-institutional collaboration, and if you give us a follow here on Twitch, you will get to see many faces of our group appear on this channel, bringing you all the things that it takes to do and communicate science out to the public. Yeah, you never know what exactly is going to be happening. For instance, bringing you the launch of a spacecraft. So, we are working in collaboration with the Planetary Science Institute. Most Wednesdays and Fridays, Dr. Matt from PSI is here teaching Astro 101, but he's away traveling this week. And you'll also catch on Sundays Annie Wilson coming to you from Youngstown State University, where she makes planetarium shows happen. So, thank you so much. We are sustained by your subscriptions, and every bit really counts. Thank you. And now for your questions. Okay. So I see Phoenix asking us to add more Vesta images. I don't know if there's more Vesta images. I do need to talk to the mission scientist and get more information on that. I see Hanny is asking, where are the Perseids in relationship to the Big Dipper? So the Big Dipper, Cassiopeia, these are all constellations that circle the North Star. So this is a northern hemisphere event. The Big Dipper in the image that I have over here is actually up and to the left. And thank you so much for the follow, Aaron73. So basically look down and to the right off of the Big Dipper and you'll be able to find Cassiopeia. Orion is not a summertime object. Right now, Orion is rising after the sun comes up. So I'm sorry, I can't help you with that one. So Larry is asking, can you explain negatively ionized hydrogen? So this is hydrogen. If you have only the protons in the center of an atom and all your electrons have gone away, you have a positively charged hydrogen atom. If instead of removing the electrons, you add electrons on, so now you have an excess of electrons. In that case, the negative charge of the electrons overbalances the core of the atom. Now here is where the language gets confusing. If your ion is a positively charged ion, then it has been negatively ionized. That means the negative has been removed. So the language is confusing. Here, where you're looking at this particular situation, the hydrogen has been heated up to the point that it has lost its electrons. I'm sorry for the confusion in these. Okay, let's see what else we have. So Klatchian Rubsoot, I'm not sure which, is saying, Parker Solar Probe has a speed record and bigger orbit means slower, but is a bigger orbit better for leaving the solar system less delta V? Do you maybe mean New Horizons instead of Parker? Parker Solar Probe is going to be orbiting the sun and staying very much in the solar system. It will be interacting with Venus and going from an orbit that takes it from close to the sun to a little bit past the Earth's orbit, to having an orbit that's instead about 70% of Earth's orbit around the sun at its furthest point, and 4 million miles from the sun's surface, not from its atmosphere, from its surface on its nearest point. So it won't be able to leave the solar system with its speed. Its particular speed record will come from how quickly it whips around the sun's surface without actually touching the sun's surface. So as it's on this highly elliptical orbit, it will slow down at the outermost parts of this orbit, and then it will accelerate as it gets closer and closer. The way Kepler put this is during its orbit, it's going to sweep out an equal area relative to the triangle formed from the star, one point on the orbit, another point on the orbit, and the star again. That area that it sweeps out is constant with time. So while it's going to be moving very slowly outwards and creating a skinny, skinny triangle, when it's moving very, very close, it's going to sweep out a larger area in the triangle. Or rather, it's going to sweep out not a larger area. It sweeps out the exact same area. It's going to sweep out a larger distance along the orbit because it's moving so much faster. So if this is our star, it's going to sweep out a super skinny triangle when it's out at 70% of the Earth's distance from the sun. And then it's going to sweep out a larger distance and the exact same area when it's close into the sun. This is just orbital mechanics. It's never leaving our solar system. It is trapped in close to the sun. The escape speed for something trying to leave our solar system actually varies with distance from the sun. So what is the please don't suck me into the sun velocity close to the sun ends up being a escape velocity once you're out at the Kuiper belt. The Parker Solar Probe only looks sideways. That is correct. Larry, yes, we should be able to start doing series soon. So Hanny is asking, how do probes make sure they are always at the right orbit? Is it correct insertion, or does a computer do live corrections? Well, for the most part, once you put something in orbit, it should stay in that orbit. It does have a variety of different interactions that can occur. It can get slowed down either through having to pass through the outermost regions of a planet's orbit. It can have various outgassing of gases that get trapped inside of it that vary its orbit. This means that we do corrections, but they're not live corrections. They're very well scheduled, very carefully thought out. So this particular mission may do corrections as it goes, but for the most part, we're counting on a very well calculated orbit where interactions with things like Venus will do most of the work for us. I'm very confused. I know why you said humpback whales. I'm just completely confused at why. Oh, I know why. Okay. So luckily, time travel isn't necessarily a concern. We are not the Starship Enterprise passing through the sun's inner atmosphere while accelerating will not fling the Parker Solar Probe back to the 80s to rescue whales. It would be cool. It would be cool if we could do that. But not going to happen. So do we have any more questions out there? Otherwise, I'm going to call it a day and go make myself some hot tea and keep making the science go. So Hanny is asking, am I correct in assuming that the Parker Solar Probe only looks sideways? I thought I already answered it. Yes, it does. Or at least when it's closest to the sun. Yes, it does. I don't know when the Borg is coming. If I did, we'd all be a little bit more safe. So thank you all for coming. Once again, this has been the Daily Space, and we are here to put science in your brain. We are part of CosmoQuest.org, and we invite you to help us map out our solar system. Vesta is not an option until we get more images. I need to work on correcting our website. But we have a desperate need for Mars and Mercury to be mapped out for research our science team is currently working on. Our channel will next go live for the Parker Solar Probe's potential launch. If there is a pre-announced launch delay, I will be going to bed. If we don't have a quick delay, I will be up and bringing you the launch tonight. And I do see Ed has a question. What is your question, Ed? Type quickly. So the 3 a.m. Eastern is tonight, which starts on August 10th and ends on August 11th. So for me here in North America, I don't go to bed before the launch. I will be tweeting countdowns as we go. Thank you for converting to UTC Cosmic Lettuce. Is there any progress on the Identify an Object project on CosmoQuest? Are you talking about the Ice Investigators project that we did a number of years ago? If you are, we have 2 published objects that were published in 2012. Unfortunately, the majority of the objects that we found either had too few detections to correctly predict their orbit, and we can only publish objects that have sufficient orbital information that we know when it will be next seen and where it is going. We do have a bunch of variable stars and asteroid data that the science team may be getting back to when they are done with New Horizons ruling their lives. So we have all of the things, and now we just need more scientists, more science funding, and all those things to be able to finish the science. New Horizons is still very actively going and will be doing its next closest encounter January 1st going into 2019, and they're in the process of steering the spacecraft to make sure everything goes correctly. So yes, Ed, we have 2 published objects. If you look through our blog, we have links to them, and you can look to see if you're listed as one of the 500 some odd people on those 2 discovery papers. So yeah, that's what we've got. So this has been the Daily Space. We are sustained through your subscriptions, and every bit really matters. Watch CosmoQuest's Twitter account today for updates on anything we hear about the Parker Solar Probe. And I will see you all when we have a spacecraft launch. Until then, have a wonderful morning, evening, or afternoon, and I'll see you on the other side. Bye-bye.